Hi everyone, welcome to fourth help session of the course E220 Circuits First. Today we are going to solve some problems, three problems. I'll read out the problem number one for you. Determine the value of current measured by the meter in the figure below. In this figure, ammeter is shown. So we have to compute the value of current measured by this ammeter. And we can see in this figure that ammeter is connected in series with this 10 ohm resistor, right? So if we compute the current through this 10 ohm resistor, that is the value measured by this ammeter. So in order to compute the current through this 10 ohm resistor, we need to apply KCL at this node, right? But in order to apply KCL at this node, this VA is unknown. So we'll first start by applying KCL at this first node. First of all, we'll create a ground node here, and the voltage of these nodes, this ground node will be equal to 0. And we're assuming this at node as node 1 and this as node 2. Other than current source, in case of all the resistors, we will always assume that current is flowing out of the nodes. That means it will always give outgoing currents. So let's start from node 1. If we apply KCL at node 1, we can see that this 1.2 ampere is incoming current, and current through this 10 ohm resistor is outgoing current, and 0.2 VA, this is also outgoing current. So we can write this. And for this, for the current through 10 ohm resistor, we know that current equals to V by R. That's why we've written VA by 10 here. Okay. After further simplification, we'll get VA equals to 4 volt. Now let's apply KCL at node 2. Before applying KCL at node 2, let's assume this voltage at node 2 be V2. And then now let's apply KCL at node 2. When we apply KCL at node 2, we can see that 0.2 VA is incoming current to this node, and these two currents are outgoing. So incoming current equals to outgoing current. Current through 30 ohm resistor equals to V2 by 30, and current through 10 ohm resistor equals to V2 by 10, and this incoming current. We can even substitute value of VA here equals to 4, and after further simplification, we'll get V2 equals to 6 volt. Now, in order to measure the current through 10 ohm resistor, which is even same as the current measured by ammeter, we'll use this formula. Current through 10 ohm resistor equals to V2 divided 10. I equals to V by R. So voltage is 10 V2 here. V2 minus 0 actually. This grounded. So finally we'll get 0.6 ampere. Now let's move to our second problem. Here we have been given voltage of these two nodes V and VV. VA equals to 7 volt and VV equals to 10 volt, and we have to compute the values of R and IS, source current. Now let's start by applying KCL at node A. When you apply KCL at node A, this 2 ampere is incoming current, and current through these branches we are assuming as outgoing current. So current through this branch equals to VA by R. This is the first term. And for this VA by 4, and for this VA minus VV divided 2. So after plugging the value of VA and VV, VA equals to 7, VV equals to 10. So 7 minus 10 equals to minus 3. So this minus 3, otherwise these are positive. After further simplification, we'll get R equals to 4. Now let's apply KCL at node B. When we apply KCL at node B, this IS is incoming current, and current through these resistors we are assuming as outgoing currents. Current to this 8 ohm resistor equals to VB by 8. Current to this 8 ohm resistor is also equals to VB by 8. And current to this 2 ohm resistor, VV minus VA divided by 2. Okay, so we can get this. So after plugging the value of VA and VV, we get this. After further simplification, we got IS equals to 4 ampere. Now let's move to our third problem. In this problem, we've been asked to compute the node voltage of the circuit, V1, V2, and VT. We have to determine V1, V2, and V3. Since we see here voltage source, connected between two nodes, we can easily write equations for this and for this source as well. Okay, so since there's a voltage source between node 1 and node 2, we can see that node 2 is in positive terminal of this source and node 1 is in negative terminal, right? So we have to write V2 minus V1 equals to 8. V2 minus V1 equals to 8. Similarly, for this source, there will be V3 minus V1 because V3 is at positive terminal and V1 is connected to negative terminal of this source. So here we get V3 minus V1 equals to 12. We got two equations, so we need one more equation to get the values of V1, V2, V3, right? Because we have three variables, so we need three equations. Now, in order to get a third equation, we have to use supernode. Here, supernode is formed because there is a voltage source connected between these two nodes and even these two nodes. And all these nodes are together. So supernode is formed out of these three nodes. So when supernode is formed, what we do? We neglect all the elements connected between the nodes in the supernode. Okay, so here supernode is formed by the combination of node 1, node 2, and node 3. So anything directly connected between these nodes should be neglected. So here we neglect this voltage source, and this current source. And this point is grounded, right? So let's apply KCL at supernode that is formed by the combination of node 1, 2, and 3. Here we don't see any incoming current source, right? Any incoming current source other than this, because this already we already have neglected this source, so we can consider this. So we have to consider only these three resistors, and in case of resistor we always assume the current as outgoing current. So there is no incoming current is 0. And for outgoing current, look for this V1, this 4 ohm resistor, V1 minus 0 divided by 4, and for this V2 minus 0 divided by 10, and V3 minus 0 divided by 5. So in this way we got equation 3. Here we don't need to further simplify this equation 3, because when we input these coefficients in using calculator, we can simply put coefficient of V1 as 1 by 4, coefficient of V2 as 1 by 10, and coefficient of V3 as 1 by 5. So if we solve the system of three equations using calculator, we can easily get V1 equals to minus 5.82, V2 equals to 2.18, and V3 equals to 6.18. These are the required node voltages. So thank you for watching the videos. See you in the next help session.